In this video, we'll look at references, and then a couple more things. We look at some friend classes and maybe the string class too, if we get to it. Okay, so what are references? References are something, if you look at it the way it's used initially, there's nothing like this in Java. But then you could also say that when we talk about Java, we have reference data types. That reference data type, that phrase comes from references, and it's a safe way to use what we will see later in C++, a thing called pointers. So references, well, how are they used? They're reference is just sort of like an alias. It's a name of a storage location. It's similar to pointer. I know we haven't talked about pointers yet. We will come to that pretty soon. But those of you who know pointers, this is like an idea very similar to pointers, but it is pretty different too. So here's how you would use a reference, and we can say that we can use it this way, but we can almost never use it like this. It's actually used. References are really used to return things, to actually pass by reference, things like that. Very seldom do we actually use it as is shown here, as I'm going to show you pretty soon. So we can set up two ints, an int Robert, and then an int with, and this is not in Java at all, an ampersand, saying that Bob is basically a reference type, a reference to an int, and it refers to, in this case, Robert. You have to initialize the reference types right when you declare them. So now you have two things that point to the same memory location. So Robert and Bob actually share one memory location. So if you had two ints, one int was Robert, one int was Bob, you would have completely different memory locations for storing things. And so if you changed Bob, you wouldn't change Robert. Here, things are different, and this is why you would probably not want to use it like this in a typical program. You wouldn't want to declare a variable called Robert and another variable which points to the same memory location. Why not? Because if you change Bob, Robert changes. If you change Robert, Bob changes, and that's considered hard to debug if you have a lot of variables like this. Okay, so Bob is a reference to the storage location for Robert, and so changes made to Bob will affect Robert. So if this is confusing, take a look at this simple example I've set up. Right now I'm not using references. I've set up two variables, a and b. I set a to 5 and set b is equal to a. Okay, now what I do is I change b, and of course, as you might expect, b will have a new value, but a will still be its old value. So if everything works, that's what we should see. Let me compile this and run it, and you should see 5 lines of output. You should see a is 5, b is 5, a is now, it should still say 5, hopefully. And when we print out b the second time, it should say 12, 5 plus 7. Okay. So make sure this should make sense. This is just typical ordinary use of ints. Okay, so now all I'm going to do different is I'm going to add this ampersand symbol right here. But the things that we get printed out will be quite different. So I'm going to save this. I hope you can remember what our old output was without the ampersand. It was 5, 5, 5, 12. Let's build this. Should compile. Okay, everything compiled, so this would not compile in Java. You cannot have an int and an ampersand in Java. In C++ you can. Now here's the big deal. You're going to run it, and we get a is 5 initially, b is 5, and then we change b and a changes. So that's the thing about references. Okay, so that's how they're different. All I did was change one character. I just added this one thing, and the behavior of the program is quite different. Okay, so I hope that makes sense. B is now just an alias for A. It's just another name for A. It refers to the same memory location. This is something that, if you're talking primitive data types, does not happen in Java. Of course, if you're talking objects, you know that in Java we can have two reference data types that point to the same object. So that's roughly sort of the idea here with references. Java is actually using The same thing that we will be using later, that is the idea of pointers, but Java uses pointers in a safe way by using references. And so this is, you can think of this as something related to the reference data types in Java. It's different in that now we're looking at primitive data types. We're not using objects. Okay. So I hope you can get used to this. It is confusing. It may be in that now you have two names for the same memory location. That part, yeah, you might ask, well, why should we declare variables like this? That actually, the fact is we almost never use it like this. So this is just an illustration to show you what references can do. The way references are used, it's really more used for methods, that is functions, and for parameter values like pass by reference, and for returning things. So this does look dangerous in that if you change one thing, you can without changing a different variable, it can appear like that variable changed somehow. However, this is useful in several cases. Call by reference or pass by reference, that's how, it's references that are used to implement this mechanism of call by reference or pass by reference. Now here's the more important thing, and this will allow us to start looking at some friend methods, friend functions. We can return a reference. This allows operator overload implementations to be written more naturally, and so we will look at this. We wrote a simple binary addition member function. Remember that for this class we set up a few videos ago. It was the class ABC, and we might, if you remember, I mentioned that's one thing that we would want to change, that is the return value. We would want to return a reference in that case. We didn't do it in that video just because we hadn't hit references yet. But now we will, and it'll look like it does the same thing. So let's just take a quick look at that. Let's go back to our old class ABC. Remember, we set up this plus operator and we returned an ABC object. Well, now what we're going to do is we're going to say this is going to be a const and it's going to be a reference type. Okay, so that's going to be the difference. That's the one last thing that we needed to do. The parameter, or the argument that comes into the second argument that comes into the plus operator, is a reference. Remember, we do that for efficiency's sake. And now we will return a reference data type. So let's do that. And it turns out the place where you use it, that is right here, you don't have to change a thing. You still say ABCC is equal to A plus B. You don't have to change a thing. All we've done is change the type of return value. Okay, and we have to change it in both places. That's the thing about C++. You have an interface file, that .h file, and the implementation. Often you'll have to change, if you make one change in one, you have to change the other one too. Alright, let's compile this. If everything works, everything should compile, and actually everything should run just as before. Okay, so this was the same output as before. C was just A plus B, so you add the int part and the double part to get the result for C. Okay, so the next thing we will do once we understand reference, how to return references, is we will change this. We will change it so that eventually, let's just do it right now actually. We'll change it so that we can just do this. Right now we cannot use the insertion operator for objects, objects of this type. And it looks like it's okay, but if we save it and compile it, we should get an error message. We should get an error message, and we get a lot of them. Okay, so there's a ton of error messages. And I'll just say that this is what we want to get working. It's not working yet, so we'll have to add a few things. We'll have to overload the insertion operator, and then this should work. So that's where we're heading next. So let's go back to usage of references. So this is used in call by reference. That's how references are, how pass by references implemented. And also now, from now on, you do a lot of this now that you know, now that you've seen what references are. We will return references. This allows operator overloading to be written more naturally, and we'll do this for the insertion operator where it is essential. And you want to think of this as returning an alias to a variable. So how do you set up a function that returns a reference? Simple, you just put in the ampersand as we just saw. You just add the ampersand. So in the case of the plus operator that we just looked at, we just added the ampersand and everything worked just as before in this particular case. So it is important to note double ampersand and double are considered different types. Just as if you had a sample function, you could have one sample function that takes in a double as a parameter, and you could have a separate overloaded sample function which takes a double ampersand or a double reference as a parameter, and those are actually considered two different methods, two different functions. But of course, as you saw a while ago, the C++ compiler, if you try to call this function with a double, might get confused, and well, will get confused if you have two functions with the only difference between them being that one of them is double, the other one is a double ampersand. So the overloading works, but the C++ compiler, if you try to use it, will say, I'm not sure which one you're trying to call. Okay, so they are different. They can be used for overloading, but of course, when you use them, you might have to somehow make it clear which one you're using. And as we've seen before, if you have a .h and .cpp file, you have to have these things matching. So you must match function and declaration. Okay, so returned item must have a reference, so it's like should be like a variable of that type. You cannot have something like x plus 5, right? You can't have x plus 5 equals something that involves the plus operator, or let's say it's something that involves a return value. Okay, so it has to be a variable. So here's a simple example. All it does is it takes a reference to something of type double and then actually returns just that same thing. It doesn't do anything. It's like pretty much a useless example. That's why it's called useless. It's trivial, that is simple, but it just shows you the syntax. And you can actually do this. This should compile and should run. All it does is if you pass in a parameter, you're going to return that same thing. Okay, it just shows you the concept. The major use of references in return values is for overloaded operators. And that's the thing we're going to look at next. So we're going to take a look at overloading, extraction, and insertion operators.